Hello everyone, welcome to another video, and in this video we will continue to explore Cave Engine and its functionalities. In the last video we did like your first game using Cave, and we created this entire scene here with a character. We imported the character, we figured out how to work with animations and how to work with the camera controller, the character physics, and also with the Python scripting. So it was a very good video, and I highly recommend that you follow along with it to go to this state. We also figured out like how to create textures, materials, how to put physics, optimize the physics mesh and all that, create templates, and many other things, of course, that you are seeing in this scene. In particular, in the end, we even quickly exported the game as a runtime in a way that you can ship to people and all that. And in today's video, I want to expand this a little bit, and I want to talk about animation, about the animation system that Cave have, because I noticed that many people asked about this in the Discord server. And by the way, folks, this is just a side note, very important. I'm very happy with how Cave Engine is going so far. The Discord community is very active, so I'm there every single day helping you and giving support, and people are reporting stuff, are asking questions, so I'm very happy for that, and I want to help you. And also I want to thank everyone here following along, because I figured this morning that Cave Engine, if you go to itch.io and if you get the game engine tag, we have 423 results, and in the most popular tab, Cave Engine is actually the second most popular game engine in itch.io right now. It's only behind Rayleigh, but guess what? It's like in front of Pico 8, Tick 80, Godot, and many other very famous game engine, including Armor 3D and even Ramply. So I'm very happy for that. And it turns out that it is actually the top most seller of the week. I don't know how itch.io counts this, but it's in the first place, so thank you so much. There's a lot of people getting the engine, trying to get started, and I am even thinking about running a game jam in January. Let me know if you are into it or not, because it would be very nice. So, and also if you want to get Cave, you can either become a patron, a solid patron, or you can get with a 40% discount this year only. So it's 2024, we have 40% discount. Many people are enjoying, so we are in the top seller. If you want to, make sure you get the Cave while it's possible. Anyways, thank you so much for the support, and of course I want to continue to help you creating games. So let's go ahead and dive into the animation system, because as I said in the beginning, many people asked about the animation system, because Cave Engine does not have a visual node editing for animations, just like Unreal or Unity does have. And why? And is the animation system in Cave simpler because of that? And the answer is no. I was actually writing this visual way to do animations in Cave in the past. So when we started using it in our studio, because the first user the Cave Engine has is not you, actually, it's us here in Uniday Studio. We make our games with it. So this is one of the huge points of Cave. We actually are actively using the engine. This is why it keeps getting simple and more intuitive. And when we started using this visual way, we realized that there was a lot of work just to replace like 2 or 3 lines of Python code. So we got rid of this visual way to do this in favor of a very simple Python way to create animations. Because in the last video you noticed here, so it's literally 1 line of code to play animations in a simple way, and there's a lot of settings that we haven't explored in animation. So just the play by name alone have a lot of settings, but the play by name actually returns an animation handle, and the animation layer and animation layer also have a bunch of things. And I figured, well, it's a good idea to showcase all that. So this is exactly what you're going to do in this video. And also, sorry for the long introduction. Many people commented in the last video, hey, can you go ahead and straight to the point and show this? Yes, I think it's good. I'll try to put a timestamp here in the video, but this is also good to understand a little bit of how Cave works. And by the way, this sphere does not have collisions. It's not a bug. It's just how it works. You can press F3 and then press 3 to see the physics in real time, which is very good. And you can see there's no collisions for the sphere. This is why it's not colliding with anything. So let's press 3 again and then F3 and continue. But also, this is important. So let's figure out the introduction first. the goal here for this series, for this tutorial series, is not exactly to make a game that makes sense, but for me to explain to you how to use Cave. So you will notice a lot of time that we're gonna be implementing stuff that makes absolutely no sense in terms of a video game, but it's necessary just to showcase the features, okay? So I will take some freedom here, and I apologize in advance because the end game that we are going to create here, not gonna necessarily make a lot of sense, but of course, if I try to make a game here, it will be much more about game design and in many other areas, and not only about how to use Cave. And I want to let this part with you, the game design part with you, to be creative and all that, and I want to focus in the engine. So I will try to explore different mechanics here, even if they don't make sense. For example, today, realize that a good way to show the animation system is to showcase how to aim with the character, because right now, if I press A or D, the character turns and there's no aiming. And if you're creating like a shooter game or stuff like that, it's very common that you press the right mouse button and then the player will also always face the camera, even if you rotate here or even if you walk. And in this case, it needs to have like a more advanced animation system, because of course I will have multiple other animations, they will blend with each other, and also the upper part of the body of my character will have to have a different animation, which is like me holding a weapon and all that. And of course we need to put a weapon in the hand of the character and all that. So this is important, very important, right? But it does not exactly make sense to make this character aim here in this game. So again, I'm just taking some of this creativity freedom here just to showcase the features. I hope you pardon me in advance. But anyways, enough talk, let's go ahead. I'll put the intro here and then we go straight to the video. So let's do some coding here, very quick coding, and then we will import some animations and start understanding how everything works. So what I want right now, I have a player, so let's put a top-down view. Let's just imagine the player in this top-down perspective here for a moment, okay? So this is the player, this ball here is a player. And right now, if I press W, it will face this direction and execute the walk forward animation. If I press D, it will face this direction and it will execute the walk forward animation, and so on and so on. I don't want to do this if I'm aiming. So for example, if I press the right mouse button, if I press W, I want this to face forward and execute this animation. But if I press, let's say, S to go backwards, I don't want to face backwards. I want to keep facing forward, but execute a backwards animation. And the same thing with left and right. And if you want to go even more advanced, you can add even another level of granularity to include the diagonals for this. And of course, the result here will be best if you have 8 animations for this, which is like forward. Let me just try to name them real quick. Put black. So it's W, it's A animation, D animation, and then you have S animation. And of course, you have the intermediates. So we have WA, you have WD, you have SA, and you also have SD. So this is the keys that I'm pressing, and of course you can see there's 8 animations here. This is the best way to do it, but for this video we will only be using 4 animations, which is the W, A, S, and D. And in between those 2 animations, we will try to blend between the A and the S. The result, I'm warning you, will not necessarily be great. It will depend a lot on the animation, but I believe that it will be enough for you to have a great understanding on how to blend different animations in different layers in Cave. So this is very good and very handy. And also, in this video, we will also handle the upper bar part of the animation, okay? And by the way, I am writing a very, very extensive documentation for Cave. You can see there's a lot of to-dos here. This is why I haven't mentioned this before, but you can see that we already have 50 pages of documentation for the engine. I'm planning to release this, and I will use this real quick just to showcase how the layer animation works in Cave, because there's this graph here, and right now we only know this first part. So by default, if you play animation in Cave, it will play the animation in the layer 0. And of course, if you set a blend, for example, half a second blend, it will blend between the two animations as soon as you play the other animation. Okay, so this is simple blending, and we are already doing this in this project right here. We are playing by name. The layer is default. You can see default layer is 0. And we are passing a blend here, 0.2 seconds, and it is doing this. So it was running the idle animation, and we start running, and then it will blend to the run animation. So this is very straightforward and very quick. The other thing that you don't know yet, the other two things that we will explore, is that we can have multiple layers. So I can execute another animation into an upper level layer, which is layer 1, 2, 3, 4, 5, or any layer you want. And the engine will blend those layers together. And each layer have a layer wave here. So you can see the default is 1.0, and of course if I execute an animation with 1.0 layer weight, it will of course completely overwrite the previous layer. So the magic here is that we can play around with the weight of each layer, and this will be very interesting, and we will explore that. And last but not least, we will come back to this soon when we go to do the animation for the upper part of the characters, is that we can have filter for individual bones. For example, if you only want the upper bone to have like the animation, you can put a layer filter and say all the upper bones will have 1.0 weight and the leg bone to have 0 weight. And it will allow you to do very complicated, very complex animation blending. And this is very nice to have in the engine. So let's go ahead and jump to this. The first thing that I would do is that I've updated the file that I have for you with the animations. And I've introduced some other animations, which is exactly the walk back, left, and right, and also the idle axis that we will be using for making the character holding an X, of course. So I'll go ahead in the player animation, and I will drop those four new animations here. So click here, drag and drop. It will import and show me this. And for this, I will disable everything, and including this create subfolder. And the animation, I will name it P walk left. Oops, if I can type, of course. And I still can't type, as you can see. And I'll do the same thing for the other animations. So let's go ahead, disable all that, P walk right. This is the idle. And last but not least, the walk backwards. Don't, so click here to import the assets. You can see that we do have new animations. And if I select this character, I can click here to walk forward, walk left, walk right, walk backwards. It's a bit weird. This animation is very ugly. But again, it's just for example. You can do better animations. This is from Mixamo, by the way. But it will do the trick. And we also have the idle that the character can see it is holding the X. And we want to interpolate those animations later on. Okay? Let me go back to the idle, and let's make this work first, okay? I'll go to my player controller, and I'll, the same way that I am checking if my player is running here, I will actually create another check. I do is aiming to see if the player is aiming. Events.active cave.event.mouse right. So if I'm pressing the mouse right button, then I'm aiming, okay? And also, I cannot run if I'm aiming, because if you notice, I don't have a run animation, run left, run right, and all that. If you want, you can add this animation, but it will make the code more complicated, and it's repetitive here for this tutorial, so I'm not doing. So my is running, I will make if I'm pressing this, and not is aiming. So if I'm not aiming, then I can run, of course. And maybe I can jump only if I am not aiming. So, and not is aiming. That way we cannot jump, you know, if this is the case. And anyways, let's continue here. Also, it's it may be a good idea to only make this the character aim if I'm on ground, right? So just do and not character on ground. Actually, and on ground. So if I'm holding the right mouse button and I'm on ground, then I can aim. Otherwise, I cannot. Good. And the first thing that we will do here is make sure that the character always face forward. Because right now, if I'm running and then I hold right mouse button, it starts walk. And I can't jump. Good. I'm pressing space. I hope you can hear me pressing. So this part is done. It's complete. Let's go ahead and make it face forward in this time, because I don't want to face sideways, because otherwise the animation will be wrong. If I'm aiming, I always want to face forward. So let's go ahead and change this real quick. So let's go here. Let me put this to the side for a moment. And here, when I'm doing this look at here, this direction, I can even change this to aim there, just to make it more easy to understand. And if is aiming, if I am aiming, the aim direction will always be forward. Which is this, probably -1 actually. Let's try this. So if I aim, you can see that the character is looking forward. But you can also see that if I rotate the camera, it will be wrong. Why? Because actually this forward here is global. It will always face this direction over here, and regardless if the camera is looking to the side. So what we want actually is to get the transform of this player, this one in particular, and figure out where is the forward for this transform. So let's do this real quick. Here in the start method, I'll just do self.trans equals to self.entity.get transform. So I'm getting the transform here. And then with this transform, over here, instead of this, I will do self.trans.get forward vector. So this is the forward of my transform. Let's see if this is any better. Now I aim, and you can see that I am looking at the correct direction. You can see that if I am not moving the camera though, it will not gonna look at this direction. So if I am aiming, I can rotate the camera, and if I press W, then it goes to this direction. You can fix this if you want. There's two ways to fix this. One of them is, instead of getting the forward vector of the player, you can get the forward vector of the camera. Or you can go to the camera component in the third person camera component and align player. You can change this to always. And then it will always align a player regardless if I'm moving or not, as you can see here. And it may be a good idea to do this using Python, using code. And doing that is a bit tricky, but I will show you how to do it, how to change this in the code. So let's keep it on movement. So it only make the third person camera only makes the player lines when the player is moving, and we will change it to always whenever I'm aiming. Okay, so let me go ahead here in the player component, and the first thing that I want to do is to get the third person camera. So I'll name it camera component, and I'll put the hint to be the cave third person camera. And then we need to worry about one thing. This camera component belongs to the camera, not to the player here. And the camera is a child of the player. And we are running the script in the player. So I need to first get the camera. And let's split this just to make things more clear. So get the camera, self.entity.get child. And the name of the child is camera. Why this? Because of course, as I said, is the name of the camera here. If it's something else for you, it will be something else here. And then with this camera, I'll get the third person cam, which is a third person camera, of course. And here in the camera, now that we have this third person camera component, here, if I am aiming, I will get the cam component, and I will change the align player variable to something else. And this is an enumeration, and the way Python handles enumeration is not very beautiful. If I click here, if I hold Ctrl and click, at least in Visual Studio, it will go to the stubs, and you can see that this is an align player rule. And here on top, there's an enumeration called third person camera component, which is the name of this class, align player rule. And then we have the options here. So in order to access this, we need to get the third person camera component align player rule class. I know it's a huge name, but just copy here and go back. This is just because Python itself does not have enumeration, and the engine, Cave engine, does have enumerations. So we need to translate in a way, and it's even if it's weird, but this is how it works. So cave dot third person camera component align player rule. It's a huge name, I know. Dot always. So this is the how we change the player role to always. Okay, and of course, if I'm not aiming, so I'll put an else here. We need to change this to not always, but to on movement. And the name of this will be here. You can see on movement. So this is how we are changing this. And if we play the game, of course, you can see it is no longer aligning, but if I hold the right mouse button, it will align. If I release, it will stop aligning. Great. So part one is complete. The second part is we need to, and this is all prep work. I'm not talking about animation yet. We are just writing code to make it align. I hope you understand this. But now we will actually start doing the animation part of it, which is nice, right? Very nice. Let's do the animation part right now. And for this, I want to individually know which keys I'm pressing. So I will move all this to individual keys. So I'll put key W, then I replace this with key W, and I'll do the same thing with all the other keys, A and D. And here, of course, I'm doing this. Good. And why this? Because then, when we are here, walking here, we can do an elif is aiming. So if the player is aiming, we will execute specific animations based on if I'm pressing W, if I'm pressing S or D, and wherever, you know. So let's do this. If key W, if I am pressing W, we will run the walk animation. And otherwise, we will execute the walk back animation. And I'll put the name here. The name here, again, as a reminder, is this one right here. 1 second. Walk back. Here we go. So we have this. Very good. And if I play the game and I aim, it goes forward, and if I press S, it goes backwards. Very nice. Exactly how we expect. So now we can do the A and D keys. And a naive way to do this, again, that will work, by the way, is to do this. Elif, key A, it walk left, and of course, if I press the key D, it will walk right. Naive way, it will work. So I can aim, left, right, back, forward, it works. Very nice. The problem is, as you can see, the diagonals they look wrong. Very wrong, actually. So we don't want to do this. We want to be smart, because I want to handle if I'm pressing two keys at the same time. All right, quick video cut here, because I was recording with the four animations that I said that we're going to be using, W, A, S, and D, but then I realized that the blend between them would be very ugly, because if you select this and go to the walk left, the character turns to the left, right, as you can see. And this will blend very well with this walk forward, because the character will be looking at this direction. You can try if you want. And we can even set the frames to be aligned, so the left leg will always be in left and all that. It's very easy to do this. But look at the walk back. The character will be, if you blend between this, the character will be looking at this direction, but it will be walking here. And this is not how we expect. If you're walking back, the character should be looking at this direction and moving to this. So it will be not good. It will be very ugly. Actually, let me real quick try to show this, how ugly it will be. So I'll go ahead here and I'll change this to be independent. So W and S is one thing, A and D is another thing. And I'll actually go ahead and put the layer to 1, because this is new for you. We will be using layers in a moment, but this is new for now. And here on top, I'll just do self.animation.set layer weight to layer 1 to 1.5 to 0.5. Sorry. So this is the way that we can give an animation. Remember this. Set this weight here for this specific layer, which is 1.0 is it will completely overwrite the previous layer with the new one, and any value between 1.0 and 0, it will lerp between those two. So 0.5 will be basically 50% of layer 0 and 50% of layer 1. And if we play this, you will see that it will be very ugly. So I'm moving forward, and then if I move leftwards, you can see that it is already ugly. But this is probably because see, it kind of works if we align the frame, and it's very easy to align the frame, by the way. We just need to get the layer 1 and make the frame be the same as the layer 0, and it will work. See, this right will work just fine. See, this is a perfect blend. Perfect, perfect, perfect. But look at the other blends. Well, this is not good. This is also not good, and it will be annoying. Not because of Cave, but because of the animations that are bad, okay? And by the way, the reason why it's destroyed here, you can see we no longer can do something else, is because we are not stopping the layer 1, and we are also not changing the layer blend. I just did this for testing, just to show you, okay? Because each layer in Cave, animation layer, they run independently. So if we play an animation layer 0, it will not gonna affect layer 1. So if I play an idle animation layer 0, but layer 1 is playing something else, it will keep playing something else in layer 1. So this is why it is not stopping anymore. But anyways, let's get rid of this, and instead, as I said, let's actually get more animations. So I went to Mixamo real quick, and I've created more animations for us. So let me actually quickly import them, and even have different animations for walk left and right. So regular procedure here, you already know. You walk forward, right, and I have walk forward left. Then I have walk back right. And I have walk back left. Good. Now let me import this, and if I select this, you will be able to see. Unfortunately, in Mixamo, I was only able to find animations with a gun like this. This is why I did not want to do this in the first place. But well, we'll be replacing this anyways, the upper part, with something else, so it's not going to be very bad. So let's go ahead and finish this. Now the code is very straightforward. Of course, we need to handle if I am pressing, first I will handle if I am pressing two keys at the same time. So if I'm pressing W and key A, so this is a walk forward left. And by the way, the order here will matter because we need to check this the two keys first, and then we check the one keys. Otherwise, it will not gonna execute properly. Now we can do this with the D key, which is forward right. And the same thing, this also needs to be in a leaf. Oops. If I can type, Jesus Christ. Great. And now it will work. So we have 8 animations and it will properly learn between them. So I'm aiming now. You can see I'm executing the same animation. It's correct. It is expected. It is very nice. Perfect. So this saved us a lot of time, a lot of trouble, and we can even stop the aiming and go ahead and have the normal procedural. And then of course we can do this if we want. And now the only elephant left in the room. By the way, I do not like this, the way that it turns left when we walk left. So I will actually replace with 2 animations, 2 extra. And I'll leave them all for you to select which animation you want. But in my case, I don't want this. And let me replace, so for the sake of the video, let me explain the other animations. You can see they are all carrying the gun. So left 2 and right 2. Perfect. Yeah, I think now it's better. Anyways, we have it here. Let's continue with the next part of this tutorial, which is how to blend another animation. I have this animation again that the character is idling with an axis. You can see here. And what we want to do is to basically make the layer 1, which is a layer on top of the previous layer. So we have layer 0, which all the walking animation, and layer 1, I want to have this idle axis animation. And actually, we can actually make this animation play every single frame. It does not matter for us here, at least now. So I just do self.animator.play by name, player axis. The blend doesn't matter here because we will only be using one animation, but I want it to loop and to be in layer 1. So if you play this, you will notice 2 things. The very first thing is that now all the animations are gone and we only have the X animation. Why? Because again, the layer weight for layer 1 is 1.0, so it will completely override everything that we have in layer 0. If I change this layer weight to something else, for example, if I do self.animator set layer weight, then layer 1, it will be 0.2, for example. You can see that, well, we kind of have the animation backs. They are a little bit weird because they are lerping between the idle and the not idle. If I put 0.5, this will be even more visible. We can see the hands. It's kind of lerping between the two in a weird way. So yes, this is layer blending on its best. And of course, we want to be smart here and blend this in a better way because this is not good. So let's get the layer weight. Layer 1. And what I will do is I will blend this to something else. Cave.math.lerp. From the layer weight to 1.0 if is aiming. So if the player is aiming, I want 1.0 in this. Else, I want 0.0. And the blend value will be 0.2. And then I'll set the layer weight to be this. And we need to adjust this so it's better according to what you need. Let's see how this works. So now I don't have any influence of this layer, but if I press the right mouse button, you can see that it blended to it. Perfect. And if I release the right mouse button, you can see it stopped blending. So we are blending between two different layers in Cave. Perfect. And this is almost what you want to do. Except that there's one thing. We don't want to blend the legs. How to do this? This is actually a very good thing. Very interesting thing. And if you go to the documentation, you know that for a layer, for example, layer 1, we can apply a layer filter. And this layer filter will allow us to define custom weights to each bone in our armature, which is very good. And by the way, this weight here will be multiplied by the layer weight. So if I have, for example, 1.0 in the upper bone, and this layer weight here is 0.5, it will multiply this. So it will be times this, okay? So the end will be 0.5, so it's good to know this. All we have to do now is to apply a layer filter. And for this, let me open Blender real quick and import this mesh. So I've imported this in Blender. I will select this skeleton and I'll put here viewport display in front and names, so it shows all the bone names. And we know that we don't want to influence any bone here except every bone that is a child of the hips here. Spine, this and all that. All the child of the hips we want to influence. The legs, we don't want to do this. Maybe we don't even want to influence the hips, but the spine, mixomerik spine. So it's a good thing to do this. Let's go ahead and apply this filter to the layer 1 of the animator. And I don't need to do this every single frame, by the way. I can do this once and it will be there, it will be stored. So in the start, I'll just do self.animation.create layer filter. So it will create for us a new layer filter and I'll put layer 1. And you can see that it returns an animation filter. So let me get this. This animation filter by default will set every single bone to 0. So if I play the game and I'm aiming, you can see that it completely stopped working. So there's no layer anymore. Because by default, the animation filter will set every single bone to 0. So what we want is to get, for example, the spine. Let me actually copy the name here in Blender. Ctrl C. Okay. Then if I go back here and get my filter, I can do set to bone. Oops, it takes bone as a parameter. So I actually need to get this bone. So let's do it real quick. I'm actually past a bone here, which is bone. I need to get the armature. So I'm getting the armature here, and then I'll do get bone, and I'll pass the bone name. So from this armature, I'm getting the armature itself, and then I'm getting the bone spine. And then I'm setting to the bone spine a value of 1.0. And if I set recursive to true, it will not only set to the spine, but to all the childs of this spine, meaning that this is exactly what we want. We want to put 1, 1, 1, 1, and all that. So let's actually try this and see if it works. Oh, we can see that it definitely works. But it's kind of weird. It is kind of weird because actually the spine here, it is getting the right thing, but this bone here, this hips bone, is responsible for the entire rotation of this. So we kind of want to include the hips in a way or another. So let me try to include this. First, let me actually get the armature in a different way here, so it's easier for us. It's cached. Let's try the hips. Now it doesn't work because if you go ahead here, the legs is a child of the hips. So it is adding 1.0 influence to all that. So let me actually go ahead and be a bit more smart. The spine, so I know it's a bone, hips. So the spine will have 1.0 influence. Maybe even like we can have the spine 1 to have 1.0. I'll try this. And then I will manually add the hips here with the recursive set to false. And I don't think 1.0 will be the way. Let's try 0.8 because I kind of want a bit of the movement in the hips. Otherwise, it will have this very weird behavior here. Let's try this. 0.3. All right. And all right, it still looks weird. And what can we do to improve this? Well, the reason, again, why this is looking very weird is because we are using the future to apply a different animation. But the problem is the hips is the one that would define, at least in some animation, the direction that the character is looking. So if it's looking left, right, and all that. But it also defines the movement here. So we cannot have a different approach here. We cannot have the rips one part to one thing and the other part to the other. If we make the hips be 1.0 aligned with the new animation, then the new animation will look correct. As you can see, it is correct, like it's facing forward, but you can see the legs is messed up. So this is how the bone in Mixamo works. And of course, if we set this to false, or in other words, if we completely disable the hips influence, you can see that now the legs looks correct, but the upper body looks wrong. What can we do this? Well, it will be very great if Cave had a very advanced feature that allows you to manually get a bone after its evaluation and manually make it look at a direction, because that way we can basically create inverse kinematics. How cool will it be, right? Well, Cave Engine does have this, and this is exactly what we are going to do. And this is exactly why I wanted to make this video in particular, to explore different animation settings here, because I believe this will be very important for us. So let's do this in particular, and the way we do this, again, I don't want to do the hips anymore, so I'm deleting. I just want the spine. Is like Cave Engine, the way it works, its workflow. Let me actually try to find it live here in this documentation, because I do have a scheme on how everything works. We do have diagrams, which is very nice. Where's the diagram? Probably here. The engine, where is the callback? I don't think it's here. I think I've omitted this. But anyways, during the handling step, it's probably in another diagram for the handling step. During the handling step, at one moment, Cave will evaluate this animation. It will evaluate all the animations you have. And if you modify something here, for example, let's say that in the update method, I get, let's try this actually. Let's do a live try here. I get the spine in the update here. So I'm getting the armature here. And then I'm getting the spine bone, and let's make it look up b spine dot look at. So this is a bone, and let me make it look at the specific vector. And I know more or less the vector, so I'll put it here. Let's make this. So technically, what we are doing is we are getting the spine, which is this bone right here, and making it look at a vector that looks more or less like this. It's a bit to this direction, okay? So in the end, the spine will be a bit like this probably, because the forward of the spine is... Let's actually try to make Blender go local. I forget. So see, this is the axis, this is the forward axis of the spine. Can you see this? And it will look to this direction, more or less. So this is perfect. This is what we want, because we want the player to be facing this. Not exactly forward, because you will find, you will realize that the animation is a bit to the side. but this is exactly what we want. And will it work? Well, not really. You can see that it's still weird. Why? Because Cave Engine will evaluate the animations after that. It will evaluate all the animations during the rendering step. So this actually worked, but since the cave will evaluate all the animations and the poses and all that after, it will overwrite what we've done. So what we want to do actually in Cave is to make this code here execute after the evaluation. And the armature in Cave, actually the animation component, have a callback for that. So I can do add post evaluation callback, and it requires a function. So we're gonna have to create a function like self.post evaluate, stuff like that. And then of course let's create this function. Very simple. And then we will move this code from here to here. And again, we have this function here as a post evaluation callback, and we are basically doing a look at. Well, very simple. And if we play the game, well, two things that we are noticing. The first thing, this is already working because all the animations are wrong. But of course, if we aim, you can see that it is working. So we need to adjust a little bit the direction that we are looking because it's a bit weird at the moment. We can adjust. Let's actually try to adjust this. For example, the up vector here will be cave.vector3. And instead of having 0, 1, 0, we have 0.2 because I believe that the up needs to be a little bit to the side. Not to the side, probably to the other side. Yeah, it's almost there, maybe 0.1. Here you go, it's perfect now, it's much better. And the other problem is that we don't want to do this if I'm not aiming. Otherwise, the player will be weird. Sounds like the spine is broken. So let's actually promote. Do you remember this is aiming function, is aiming method that we created here? Let's actually promote this to a variable here. So here in the start, I will create something like this. Self.isAiming equals to false by default. I'm not aiming by default. And then I will do a Control F, and now I will put a self.isAiming before every time we use this. Good. And now here in this pause evaluation callback, I will only do this if self.isAiming. Good. So if that, you can see that it is no longer doing this if we are not aiming, but if we aim, of course, it will do this. Very nice. And of course, the same way we do this, we can use this system here to pretty much do anything else. For example, we are making it look somehow forward here, but we can make it look at the direction that the camera is facing by getting the camera transform, getting the forward vector, and making it go to this forward vector. I think that it will be too much work for us here, so I will leave it for you, right? Because we will have to afterwards change it a little bit to compensate for this offset that I'm adding here. But anyways, actually, I never remember the... Let's actually try this. It's completely wrong. Maybe 0.7. Let's do this. I just said that we're not going to do this, but I want to do this. So the camera is already here. Let me get the camera transform. And let's actually comment this and do self.cam get forward. Let's see how it goes. See? Now the character is perfectly looking up and down. And of course, we can split this load. I'm not going to do this in this video because it would be too long, because we are applying all this this transformation to the spine, but we can split this into spine 1 and spine 2. For example, this we are really doing the look at. We can do look at move, and the parameters here. The second parameter is the lerp value, so we can put 0.2 in this case. And then it will no longer do like a complete lerp, but then if we keep getting all the spine 2, spine 3, spine 4 and all that, and increasing this lerp, it will do an arc as we expect. You know, it will be like, if I'm looking up, instead of doing this, which is broken spine, it will be 0.2 here, then 0.4 here, and then 100% here, and it to do this. It's still a broken spine, but it's less of a broken spine, I would say. Anyways, you can do this, and it's very easy. Again, now we are facing the right direction. And one last thing that I want to do in this video, now we have this more interesting animation system, is I want to put the missing piece of the puzzle in the hand of this character. I want to put an X in his hand because I believe it's a missing piece, right? So let's do it right now, very quickly. I will get here, I've already have an X model here, very nice model by Yuri Mizyuk. It's game ready. It's 1000 polygons and 500 vertices, a bit high-res, but it's okay. And it is CC attribution. So I'll leave the link for this XC in the description for you to download. And if you download and extract, it will be folders like that. If you go to source, it will have another zip. So I should extract it again. And inside the model, you have the textures and the model. I've downloaded DAI, which is a format that Cave will support out of the ones available here. So let's go ahead, I'll save this, and I will first, let's actually create a folder here for the X. And I'll first import the textures, so just drag and drop all of them, except the ambient occlusion, I don't want this. And then I will drop the model. Good. I don't want the template, I just want the mesh and the material. Let me actually call this X mesh. And X in material. I don't want to create a subfolder. I will import this, and you can see that unfortunately it was not linked to the material, but it's not hard. You can just put the albedo here, the roughness here, the metalness here, and the normal map here. And if I update this, you can see that it really have the cool texture, all that, super nice. See, very, very nice. And let's put this in the hand of the character. How to do this? Well, first thing, I will select this and I will make it a child of my proto mesh, which is the entity with the animation component. You can see here. So with the X in mesh, what I'll do is I'll go ahead here and add a new component, graphics, animation socket. An animation socket, if you have it in an entity that is a child of another entity with an animation component, it will allow you to make the parent of this entity a bone. So if you see here, I can select a bone, I can put the hips, and you can see that it is now parented to the hips of my player. It's a bit huge here. Let me actually reduce the size. It's actually good because I can, for example, put this in the spine. And then if I want, I can rotate this. Then the rotation will not gonna work here because it will be overrated by this. But I can adjust the rotation here. And the position offset, well, it's huge position. Just need a little bit. Maybe I should rotate this more, add more offset in the position here. And with that, very simple, we have a giant X in the back of my character, and it is working. So, and of course you can go ahead and expand this to make, for example, the player get the X from its back. Let me actually do this. It's not going to be hard. It will be actually very simple to do. Let me just reduce the size because I figured that it is too much, even for this simple character. And let me actually 5. The Z-axis, oh well, this one is good. But I'm not gonna make the animation for this video because it will be video will be too long. But I will show you how to swap them because it's a simple trick that you can do. So it's here, it's in the player's back. You can see, and I want to make it go to the hand of the player if we do this. So I will rename this to axis back. And I'll create a copy with Shift D, and I'll rename the copy to axis hand. And this copy over here, I will make it parent to the hand of the player. So let me go back to Blender and figure out the bone for the hand, which is this Mixamo right hand. Let's go ahead. Right hand. So it's now in the right hand here. We need to reset the position and also play around, of course, with the rotation. Then we adjust the position a little bit to fit exactly the hand of the character. Good. So we have this X in the hand of the character, and now we have two X's. Of course, the animation is not good because it's not carrying holding anything, but you can see here we have an X on his hand, which is good. So now what I need to do is to toggle the activation of those two X's. So let's actually go to the code, and in the start method, I'll get self.axis hand. It to be self.entry.get child axis hand. Recursive is true. And I'll also do axis back. And then with those two x's, what I will do is in the update method, right in the end, I will do self.axis hand.set active. It requires a value, and the value will be self.isAiming. So if I'm aiming, I need to be with the X in my hand. And it takes a scene as an argument. We can, let me actually get the scene here. Self.entry.get scene. And also the X back, it will be the opposite of this. So it's not is aiming. So if I'm not aiming, the X is in my back. Okay, very simple. Let's go back to my game and see if this works. You can see that the X is in my back and not in my hand. If I aim, the X is in my my hand. If I jump, it's here. Perfect. Very nice. So this way, we did somehow a more advanced animation system using Cave, and this way you also figured out how to use layers in Cave, and also how to use layer weights, and also how to use layer filters, and also how to use animation sockets. So it was a huge win for us, and I believe that you can learn a lot and evolve your games using Cave with this approach. So long tutorial, but I believe we learned a lot. And let me know if you have any questions or comments below, and I see you in the next video. Bye.